So, Unit 1.1, Intervals, Domain, and Range. These are the vocabulary words you will be seeing throughout this section. So first of all, here's an introduction to some of these intervals. So you'll notice that you've got finite intervals and two infinite intervals, and these are the notations that you'll be using: inequalities, set notation, and interval notation. This just represents that your x value, your variable, will lie between, or your numbers will lie between two endpoints. And then here you will have an endpoint, and either you will be going beyond, above, greater than, or you'll be going below. And say if it's on a number line, you will see how that works out. And then you've got two other notations to grow accustomed to. If you know your inequality, then you understand your set notation. And then for the interval notation, the number is where your interval is part of your interval. And when it's greater than, your infinity is the end of your interval. When you have an inequality which is less than or equal to, less than, the infinity begins your interval, and you end with your endpoint, the number. We'll become accustomed to how that is written. So here we begin with the number lines, and you'll see how we write a finite interval, which means you have two endpoints. So if you'll look on our left side, so you have endpoints -3 and 2, and so you've got your inequality, -3 less than or equal to x, less than or equal to 2. Once you have that inequality, you've got your set notation. You just have brackets, you'll see those, and this vertical line means such that, so you read it as x such that -3 is less than or equal to x, less than or equal to 2. And then here is your interval notation, and you'll notice it looks like an ordered pair with square brackets around it. And the other side, the only thing different about any of this notation is that you have an open circle, so you have no line in your inequality underneath the very first inequality symbol, and when you get to your interval, you have a parentheses instead of the square bracket. If you look at a full number line, totally filled in, that interval notation is -infinity to +infinity, representing the entire number line. And infinity, you cannot stop. That's not a number at infinity. So we have parentheses rather than square brackets, and infinite interval. So there is the vocabulary for you. What numbers are in this interval, part B? That would be all real numbers, and on the number line, and that's where we get this fancy looking R. That represents all real numbers. That is a set of numbers, and we will be talking about lots of sets of numbers. 2, what are all of these different intervals right here have in common? Obviously the same endpoints, 0 and 5. However, the first interval, 0, 5, with the square brackets, includes 0 and 5 because you have the square brackets, so this would be closed circles. The next interval, which has the square and parentheses, it includes 0 but not 5, so that would be an open circle at 5, not including 5. And then the last interval with parentheses only, no square brackets, does not include 0 or 5, so that would be open circles at both. If you have a symbol U, that is the union of two sets. Here's what it looks like. You put together two intervals on the sketch of a number line, and this is what it would look like. The union, take all of both solutions, describes all but 0. When you need to recall that all x values of a function are the input values or domain, and the y values of a function are the output values or range. So there's not a table, so I have that over the graph. A candle 6 inches high burns at a rate of 1 inch every 2 hours for 5 hours. So right here, 1 inch over 2 hours, reduce that, you've got 0.5. So that's 0.5 inches per hour. And so writing this as a function, if you come through here, the candle's height, so we've got a function h of t, begins at 6 inches, and it's going to burn, so it's going to lose height at 0.5 inches per hour times the time. It's going to burn for only 5 hours. So the domain is only going to, x values, is going to begin at no time to the 5 hours. So when we use this function and complete this table, like you guys did for the 0 unit as we were doing those functions, we've got 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. Complete the function, and here is the height of the candle. 5.5, 5, 4.54, 3.5. And here's how it gets graphed. And that gives you your range, your y values. If the candle height is increased by 2 inches, how is the function affected? So remember, the beginning height was 6, it is now 8. And if we put in the 1, 2, 3, 4, 5 as in the amount of time that happens and complete our function, here is what happens to the height of the candle. So originally the range was 3.5 to 6. With the taller candle, the range is 5.5, beginning with the smallest number, to 8 over that restricted domain. So it's only burning for 5 hours. Last problem, the given function and domain, draw and identify the range using the same notation. So we've got this linear function, and this is where what the domain is. So here they're starting you out, and they're telling you the graph is array. So how do they find that out? And it has an endpoint. So remember, you start with x, so you know your x value, -3. And they're saying the range is going to be this function of -3. So I came down here. What does this mean? So you're going to put that -3 in and evaluate it. And what you come out with is 1. So here's the beginning point. And they told you it's just greater than. So it's going to be an open circle. Continue to graph that. And if you know that this is your y-intercept, and you've got a slope of -1 over 1 right there, then you're going down 1 over 1, and you can complete that line, and then it is a ray. And then the domain and range, you've got your domain, and we finish the range right here. And that's it for your notes.